All right, I will say, if you already did the quizzes review that's in here, that's fine. But if you haven't already done the quizzes review, when you're doing the review, and also when we're about to do this Kahoot, and when you're doing your test, you might want to, it would benefit you to use this thing that's right up here on your Canvas, up towards the top, like right over where it says grades, it says chemistry reference chart. And if you click on it, it's gonna, it'll say, you have to open it in a new tab. So it's gonna do this. So you open it in a new tab, and it's a file, it's a PDF that has it. First off, it has a periodic table on it, okay, with all the names and the symbols and some other information about the elements, okay. So you can see their atomic number, and up here's the key. So here's their atomic number. This is their atomic mass. This is their electronegativity value down in this corner. And then depending on how the symbol's written, that tells you what state it's in at normal conditions. And then there's all this other stuff, like right down here, here are all your prefixes for your covalent compounds. Here, this little chart right here that says common positive ions, what these are all of the transition metals that could have multiple charges. And it tells you kind of what their two most common ones are. So for example, it says here it says vanadium, and it says 3 and 5. So that means I could have like vanadium with a Roman numeral 3 in the name, or I could have vanadium with a Roman numeral 5 in the name. So any of the ones that have 2 listed, they have to have Roman numerals for whichever one it is in the name. The only ones that don't need Roman numerals are zinc, silver, and cadmium, because they're the only transition metals that only have 1 charge. So these are like the most common. Some of these elements actually have like 3 or 4 or 5 charges, but these are just the most common ones for each element that you see. So it has the number listed here, so you just need to make sure you know the Roman numeral that would correspond to, okay? And then on the second page down here on this left side, here's a list of common polyatomic ions. So it has their name, and it has their formula here with their charge, and you can always zoom in on this. The rest of this stuff, like we haven't gotten to this yet. This is all stuff that we'll get to second semester. Most of it is. There's a few things that we might have used earlier this semester, but most of the stuff we won't get to until second semester. And then up here, you do have that little electron chart, like when we did electron configuration. So it goes like 1s, 2s, 2p, 3s, 3p, all that kind of stuff. So you have that up here. This side over here on the right where it says organic prefixes, that doesn't really apply to us. Organic, we don't learn organic names and formulas in this class. That's something my IB students do. So if you want to learn about that, you can take IB chemistry next year. And we learned all kinds of other advanced chemistry stuff that we don't learn in this class, that you would learn more like in a college chemistry class. So this has, again, so it has periodic table, so you can look up your names and your symbols for your elements, and you can look at what group they're in. So you'll know the charges, okay? Like remember, group 1 is +1, group 2 is +2, and then I skip these because they're the ones that are multiple charges. But over here, I have like +3, and then nitrogen's group would be -3, -2, -1 for the group where fluorine's at the top, and then noble gases are 0. So you can use the periodic table to get your names, your symbols, and also to remember what group they're in to look up their charge. And then you have the list for the prefixes for covalent. You have the list here of the transition metals that would have need Roman numerals. It tells you which number. So you just need to know, I need to know the 3 would be like the 3 I's, or a 4 would be IV, okay? And then your polyatomic ions are down here that you might need to use. So those are kind of the areas for this unit test that would be most helpful. The other stuff is extra stuff for other units later, okay? So again, I would say have this open during the Kahoot we're about to do, because there are going to be some names that have polyatomic ions, or Roman numerals, metals, or you're going to need prefixes. So, and it also has a periodic table. So have this open in another tab during the Kahoot we're about to do. And then I would also say have this open in another tab when you're doing your test, okay? This is something that you're allowed to use on your test to help you. And you can also use the stuff that's in Canvas, because I know in Canvas there was a slightly different list of polyatomic ions, and then the Roman numerals and things like that. So having said that, I'm gonna go back here. One thing I will tell you, if you've already done the quizzes review, that's great. If you haven't, you can still do it later over the weekend if you want to do it to practice before your test. And then the other thing is, after we do the Kahoot review today, and then after you've done your quizzes review, if you are like still struggling to understand some of them, even after we go through some practice and stuff today, I would highly encourage you to look at this page at the very end. It says extra tutorial videos for chemical names and formulas. I have put several videos on here that are tutorial videos for all of the different kinds of names and formulas. And they go through kind of what they are. They talk about examples. And so you can watch it and maybe watch an example, and then you can pause it and maybe try to do the second one or the third one on your own, so you can kind of check yourself. So the first one, you have covalent. These are our covalent compounds, the ones with the prefixes. And then there's several with ionic compounds, because here's one with transition metals. So those of you, if you're struggling with the transition metals and knowing like how to figure out what the Roman numeral is for the name, this shows you, and it goes over several examples, and that's the intro. And then there's one here that has several practice problems right after it. So you can watch the intro, and then in this next one, there's multiple practice problems where you can kind of try to practice it and pause it yourself, and then see if you can figure it out, and then, you know, watch the end of it to check yourself. For writing just basic ionic compound formulas without transition metals, there's one here. And then after it, there's one with practice problems. Ionic compounds that have polyatomic ions, there's one here for that. And I think some of these might have transition metals in them too. I think it might have the combo. Here's one for doing the formulas for transition metals. Okay, how do you do the formulas if they have transition metals? And then there's another practice video for that. Here's how you tell if something's ionic or covalent. So looking at the name or the formula, how do I know if it's ionic or covalent? And then the last two have to do with acids. So how do we name acids? And then there's some practice problems with the different types that we just talked about on Monday, okay? So there's several different ones here, depending on which area you need to work on. You can watch some of them over the weekend if you want to practice and review more. Okay, so I'm gonna go ahead and go to the Kahoot, and I'm gonna start to play. Hopefully we'll be able to do this live. Sometimes it works, sometimes it kind of lags, but all right, so the pin, can y'all see the pin up here? 24614 is your pin number. So you go to kahoot.it and put in 24614. Oh, there goes the music. They got us like holiday themed music now. So if I go full screen, can y'all still see the whole thing?
Yes.
Okay, thank you. Aw, Mariah's got her snowflakes. Isn't that cute? I wish y'all were here at school to help us decorate the hallway. We're making a bunch of snowflakes and ice blocks. It's very tedious. All right, we only got half of us in here. Are the rest of us getting in? Or are we not gonna play? Yeah, we got Austin in. All right, I'm gonna wait about 1 more minute to see if anybody's having like a lag getting in, and then we'll start, okay? So, and remember, if you don't have that reference chart open, you might want to open that in another tab, so that you can look up your elements and look up your polyatomic ions if you need to. All right, guys, I'm gonna go ahead and start. If you're not in and you're having trouble getting in because it's just taking too long or something, you can just kind of remember the pin. It's 24614, and you can keep trying to get in, and you might just maybe miss the first question or so if you're having a lag. Uh-oh. All right. So the reason that these types of questions are on here is you're not necessarily going to see a question like this on the test. But in order to write something's name or formula, the first thing you need to know is what type of compound is it? Because if you don't know which category it is, then you're not going to use the correct rules to write the name or formula. So how do I tell which category it would go into? What makes something covalent?
If both elements are non-metal.
Well, they're both nonmetals, right?
Yeah.
So for covalent, it'll only be two elements, and both of the elements will be nonmetals. Okay, and so this is where you would need to maybe look on your periodic table if you're not sure where the elements are located. You can look on your periodic table, and both sulfur and oxygen are on the right of our stair-step line. They are both nonmetals, and so that makes this covalent. If it was ionic, what would it have to be? What would it have to have for it to be an ionic compound?
Metal, non-metal.
Yeah, so it would either have to be a metal and a non-metal, or it could be one of those ones where it has a polyatomic ion, so it has more than two elements. So anytime it has more than two elements, typically that's going to be an ionic one because it's going to have a polyatomic ion in the formula. And then how do I know if something is an acid? You guys remember from Tuesday? Acids all have something specific in their formulas.
OH.
That's the base. Bases all have the OH. Acids, they all their formulas start with hydrogen. They all start with H. Okay. So if you look at a formula and it starts with H, unless it's water, unless it's H2O, it's going to be an acid. Okay. Oh yeah, all right, we all got this one. So this one is ionic because titanium is a metal. It's actually a transition metal. So if I wrote the name for this one, it would need a Roman numeral, okay? In order to figure that out, that's where I have to do that thing where I work backwards. So if you watch those tutorial videos later, he'll go through step by step how to do that, and we'll look at one after we finish the Kahoot. Hopefully we'll have a little time. But basically I look at my negative, I look at my anion, which in this one is the Cl, it's chloride. And I need to know what's the charge for chloride because that always has a set charge, it doesn't change. And so based on chloride's group on the periodic table, it's in group 17. And group 17, they always need to gain one electron, so they always have a charge of -1. So I know that the Cl is -1, but there are 4 Cl's because of this subscript. So it's actually 4 times that -1. So total, the negative charge is -4. And remember that for ionic compounds, my charges, the pluses and minuses, have to balance out and equal 0. So if the side with these 4 chlorides is a total of -4, then the side where my positive charges has to balance that and be +4. And then since there's no subscript here on titanium, that means there's just one titanium atom, which means, so that means that one atom of titanium has to be a charge of +4. So the name for this one, I would write titanium, and then I'd have a Roman numeral 4 in parentheses, that's the IV, and then I would have chloride. So titanium 4 chloride would be how I would write the name for that one. All right, so this is one where you have to know your prefixes. So remember, they're on that reference chart. So use your reference chart, look it up, okay? Carbon tetrachloride. So carbon is just gonna be C, it doesn't have a prefix, so that's just C. Chloride is Cl, and then the tetra, that's my prefix. If I look up on my list of prefixes, tetra is 4, so that's why it has to be D, CCl4. If it was B, what would B, if it was B, what would that name be?
It will be di.
Yeah, it'd be carbon dichloride, and C would be carbon trichloride. A would be carbon monochloride. Okay. Oh, we got people moving up. All right, this is what we just did on Tuesday, so this might not be as fresh in your mind since we just learned it, but you can look up in your notes if you need to. If you're not sure, we will go over it. All right, so we're gonna go over this one because I know the acid, we just learned these on Tuesday, so they're, you know, we haven't practiced with it as much yet, maybe. All right, first off, looking at the name, okay, the name says perchloric acid. So number one, we know it's an acid because it's got the word acid, so we know the formula is gonna start with hydrogen, it's gonna start with H, okay? I need to look at how this name is written. The first thing I wanna look for, does it have hydro at the beginning? So does it have hydro at the beginning of that name? Right here.
No.
It does not. So if it does not have hydro, that means it cannot be D. Because remember, hydro is for the binary acids. Okay, remember the oxy acids, all the ones like the A, B, and C that have oxygens, they don't have hydro. So because there's no hydro, D, option D should be eliminated first, okay? Then between A, B, and C, now this is where I need to know the name of the polyatomic ion. Okay, this is where you're going to need to look at your list of polyatomic ions. Okay, ClO2 is chlorite that ends in ITE. ClO3 is chlorate that ends in ATE, and ClO4 is perchlorate. So because the name of the acid ends in IC, we're looking for the ion that ends in ATE. So that means we're looking for perchlorate, which when you look at your list of polyatomic ions, perchlorate is ClO4. So the correct answer should be C. And so again, the way you have to go about doing acids, number one, look for the hydro. If there's hydro, then it's automatically got to be D because none of the other A, B, C can't have hydro. But since there's no hydro, that means we eliminate D. And then to figure out which of the A, B, or C it was, we need to look at the names of each of these polyatomic ions. And remember that if the acid, if it ends in IC, it's going to be the one that ends in ATE. If it ends in OUS, that's going to be the ones that end in ITE. That's how they correspond. All right, this is a tricky one because this has got a Roman numeral and a polyatomic ion. All right, so we're gonna split. So it looks like we had most of us either picked A or B. Okay, so we got the Roman numeral right, most of us. Okay, it was the polyatomic ion that threw some of us off. So once again, so first off, I really can eliminate, if I know the name of that polyatomic ion, two choices can be eliminated right off the bat. If I look up on my list of polyatomic ions, PO3 is phosphite. It ends in ITE. So that's just straight up, look that up on your reference chart. PO3 is phosphite. So I can eliminate B and D from looking up the name of that polyatomic ion. Then for the first part, CO is cobalt. Okay, so I need to know what Roman numeral. Is that going to be 3 or 1? The way, again, that I do that is I look at what is the charge on this negative ion. So PO3 we just identified was phosphite. And when you look up phosphite on your list of polyatomic ions, its charge is -3. So there's only one phosphite here. Okay, PO3, that's one of it, and it has a charge of -3. That means since there's only one CO, there's only one cobalt here, that cobalt has to be +3 in order to balance out and equal 0 for the whole overall compound. So if you know the polyatomic ion is phosphite, you can eliminate B and D, and then you have to determine that charge by doing that little bit of math, starting with your negative charge and then calculating backwards to figure out the positive charge. Oh, we got a new leader. Luis is coming from behind. All right, most of us got this one. About half of us got it. Okay, so let's look at these choices, because this is a type of a question where you have to look at each choice to evaluate which one is the correct one. Okay, so what can somebody tell me what is wrong with letter A? Like, why does letter A not match?
The fate.
Yeah, so exactly. If I look at the name here, it ends in ATE, sulfate. That implies a polyatomic ion. Anything that is an ATE or ITE is a polyatomic ion. This is not polyatomic. This is just a metal and a non-metal. Okay, so BAS would be barium sulfide. It would end in IDE. And if I had barium sulfate, that would be BaSO4, because it would be a polyatomic ion. So that's wrong because it's not the negative ion doesn't match. Okay. Can somebody tell me what's wrong with letter B?
Monoxide.
The first one says dilithium.
Yeah, so it's not the monooxide. That's not what's wrong. What's wrong is it shouldn't have any prefixes. It does not need the di. It should just be lithium oxide, because it's an ionic compound. Lithium is a metal and oxide is a non-metal. And remember, ionic compounds never use prefixes. Those are only for covalent, the ones that have two nonmetals. So B, we'd have to get rid of that di prefix for it to be correct. Okay. C is actually the correct one. Calcium nitride, that's an ionic compound, and it's binary. It only has a metal and a non-metal, no polyatomic ion. And so this is the correct formula. And the reason is because calcium's charge is +2. Nitride's charge is -3. So when I crisscross them and I write the subscripts, I end up with Ca3N2. So that one is correct. What's wrong with letter D? Anybody know? So because Cu is copper and I is iodide. What's wrong is the Roman numeral. Okay. Because again, if I do that method where I work backwards, iodide is -1, and there are 2 of them because of the subscript. So there's a total negative charge of -2 here. And that means in order to balance and equal 0, the copper, since there's only one copper, it has to be +2. So this Roman numeral would have to be a 2 for D to be correct. All right, so let's see. So 4 of us got this one right. So first off, if I look at this formula, I have N and I have Cl, so nitrogen and chlorine. Both of those are nonmetals, so that means the name is going to have prefixes because it's covalent. So then on the first element, on the N, see, okay, nobody picked D. Okay, because remember, we don't ever use mono on the first element. So D can't be it because we would not say mono nitrogen. Okay. So we know, and it can't be A. What's wrong with A?
It has nitride.
Yeah, so the first element, we don't change its name. We just leave the from the regular name from the periodic table. So we don't need to change it. We only change the ending of the second element, okay? And then between B and C, you have to have a prefix because you have a number 3 here. The second element always has to have a prefix. Even if it was just 1, we would have to say monochloride, okay? But there's a 3 here, so we need to use the correct prefix for 3, which is tri, and that makes B the correct answer because it's nitrogen, and then trichloride because of the 3 on the Cl. All right, let's discuss one because so many of y'all picked A. All right, so first off, did anybody pick the last one? Okay, one person picked D. So D should have been eliminated like really fast. Why should D have been eliminated like first thing?
Because he has dihydrogen.
Well, that, but really I was thinking more along the lines of it starts with hydrogen, which means it has to be an acid. So that means it can't be D, but you're also correct. We wouldn't say dihydrogen either. So D should be eliminated because D is the only one that doesn't say something acid. And so we know it has to be an acid because it starts with hydrogen, okay? So then between A, B, and C, I have to know which category is it. So I know most of y'all picked A, but can somebody, now that we know A is not correct, can somebody tell me why A is not correct? Or how do I know A is not correct? What types of acids use hydro?
Binary
Yeah,
acids?
the ones that get hydro are binary. Are there only 2 elements in this formula?
No.
No, there's 3. There's hydrogen and then carbon and oxygen. So it can't be hydroxylic because it's not just hydrogen and one other element, okay? So then between B and C, now this is where you need to look at the name of your polyatomic ion. If it's oxalic acid, then it's going to be oxalate. If it's oxalous acid, it would be oxalite. And if you look at your list of polyatomic ions and you find the formula C2O4, the name of C2O4 is oxalate. So since it ends in ATE, that means that it would change to IC. And so B is the correct answer. So again, kind of eliminating your answer choices, D goes out first because it's not an acid. And we should know it has to be an acid because of the H at the beginning of the formula. And then A is eliminated because it's not binary. It's one of those oxy acids because it has oxygen, hydrogen, and then a third element. And then between B and C, we need to just look at the ending of the name of the polyatomic ion. And since it's ATE, it would be the acid that ends in IC, which would be letter B. Okay, most of us got this one, but let's go ahead and take a look. Okay, so what is wrong with letter A? Why is A not correct?
They would cancel each other out.
Yeah, exactly. So if you do that crisscross method, if you don't do, depending on which method you do, you could do the balancing of the charges like we did in the tutorial videos, or if you do the crisscross method like in the notes. But if you do the crisscross method, remember you always have to reduce the subscripts for the ionic compounds. So even though they are both 2s, and if you do the crisscross, yeah, you would cross the 2s down, they can both be reduced, okay? So it should just be CUS. Because if you do the method from the tutorial videos that we watched, you just look at the charges and you balance them. And so 2 plus and 2 minus, as I think that was Mariah that said that. Mariah said they would cancel out, and I would just need one of each. So the formula would just be CUS. What's wrong with letter B?
CL as a subscript of 2.
Yeah, so if we look, this is a +2 and this is a -1, so we would need 2 of the CLs in order to balance it out. So the CL should have a 2 subscript behind it for that one to be correct. And then what's wrong with C?
NA shouldn't have a subscript of 3.
Yeah, so if you look at the charges, this is a +1 and this is a -1, so it should just be NaNO3. The Na does not need that 3 subscript behind it. So D is the correct one. You have a +2 and you have a -1. So that means we need 2 of this polyatomic ion. And since it's a polyatomic ion, we have to put it in parentheses and put that 2 subscript outside. So that's the one that is correctly written. All right, this is our last question coming up. All right, this is it. Determine who's going to win. Ooh, okay, we're gonna split on this one. All right, let's look at this one. Okay, so first off, nitrogen and hydrogen, both non-metals, so it's covalent. Now, some of you guys might be like, why isn't this an acid? It's not an acid because the hydrogen is not at the beginning of the formula, okay? So this is just considered covalent, okay? And so I would use the prefixes. So the first element is nitrogen, and I don't change the ending of the first element. So B and C should be out, because they both have nitride, and I don't change the ending of the first element, only the second one. So B and C are out because of that. So, but it is di-nitrogen because I need that prefix for di for 2. So then between A and D, I need to know what's the correct prefix for 4. And on our list, the correct prefix for 4 is tetra, not quattro. Okay. So our prefixes come from Greek prefixes, Greek and Latin prefixes, not from other languages. So other languages, yeah, you have quattro, or if you think of like in math, you have quadrilaterals, because quad is usually another prefix for 4. But for our names, we use tetra. Okay. All right, let's see who won. Hey, Mariah. Hey, Luis. There we go. Who is it? Who's it gonna be? Hey, Cody. We got Jose and Jasmine R for our runner-ups. All right. All right, I am going to switch over to my iPad just so really quick, because we had some people that were asking about the Roman numerals, so I wanted to do a quick example with you guys. But again, after I go through this, if you're still having trouble, then I would definitely encourage you to watch those tutorial videos later on, okay? So. Okay, so I'm gonna write a formula here, and I'm gonna go ahead and give us one with a transition metal, because that's what we kind of want to practice here. So I'm gonna pick, I'm gonna do AuCl3. So I'm gonna do one that's just binary first, and then if we have time, I'll do one with a polyatomic ion. So anytime you look at ionic compounds, you need to look at your transition metal, okay? And Au is gold, and gold is a transition metal. So that tells me this needs a Roman numeral. This is where you can use that reference chart, because that has all the transition metals with their most common charges. So use that to help you. That'll at least help you narrow it down to like 2 possible numbers, and then you can kind of do your math to figure it out. But this is gold. So I know this is going to be gold something, and then Cl is chloride. So I know that, okay, because it's ionic, there's no prefixes. Now, for the charge, or for the Roman numeral, I need to look at my negative ion, the Cl. Cl is -1 because it's in group 17. It's a halogen. But there are 3 of them. The subscript down here tells me there are 3 Cls. So I'm going to write a couple more. So all together, if I add up all those negative charges, what's the total negative charge here? Yep, it's 3 minus or negative 3. So what that tells me is that my positive charge has to add up to positive 3. But in the formula, if I scroll back up here, is there a subscript on this gold?
No.
There is not. So that means there's only one AU. So that means all of it has to have plus 3. And that means that this would be Roman numeral 3 inside here. Okay. Now, if you have one with a polyatomic ion, it's the same basic process. Let's see. I'll do. Okay. This process is the exact same thing. Okay. Iron's a transition metal. So I'm going to look here. This one is a polyatomic ion. So I can look up on my list. PO4 is a negative 3 charge. If I look that up on my list of polyatomics, and then it has a 2 subscript. So that means that there are 2 of them. So total, what's the whole negative charge here?
Negative 6.
Negative 6. Okay. So that means that the positive side has to be positive 6. But if I look at this formula, how many irons are in here?
3.
There's 3 of them. So that means the positive 6 is divided over those 3 atoms. So if I do that in my head, I can do 6 divided by 3. So that means each one of them has to be plus 2, which means that in my name, I would need a Roman numeral 2. So that would be iron, because Fe is iron. Roman numeral 2, because that's what we just calculated it would be right there. And then PO4 from your list of polyatomic ions is phosphate, is an ATE. So hopefully, guys, that helps to clarify and answer the questions that somebody was asking earlier.